I hope my screen is visible to both of you. Yes.
Yes, sir.
Yes. Thank you for the confirmation. Okay. So we know that as soon as we double click on our software, something like this, if you double click after installation, you can get the software to the desktop, and you can double click and you can run. So as I told you in the last class, that after double clicking, you will get simultaneously two window. This window is called as the Open VSP window, and this window is called as the geometrical browser window. Okay. In this geometrical browser window, we have set of components. These components are the inbuilt components. Component is nothing but default component. Like we have fuselage, we have to select, we have to add, and also we have wing, we have to select that, and we have to add. These all components, that may be wing, fuselage, and all other different geometrical browsers what we have, or geometrical components what we have, number of seats, ducts like engine, disc, cone, box, group, box. Okay, all these components, geometrical components, you can use. You can We know that the wing what we have, it's a default wing. It is having its own parameters. That is a span so and so, or root chord so and so, area so and so, aspect ratio so and so. So you can change this wing as per your requirement. Okay, so here the major role of this software is simple, is that to complete the conceptual design part. I hope you have came across with the aircraft design subjects in your seventh semester, where you have understood overview about the design process. So under this design process, or aircraft design process, we have three major process. First one is our conceptual part. Okay, first part, or first phase conceptual, and second one, that is preliminary step, and the third one is the detailed design. So generally I'll call this as CPD. Okay, I hope you know what is conceptual design, what is preliminary design, and what is detailed design. Yes or no? Yashvi
Yes, sir.
and yes. So conceptual design is nothing but you will be applying your basic aeronautical or aerospace design knowledge to implement on a rough sheet or on white sheet before proceeding for the design and manufacturing. That is called as the conceptual phase or conceptual design part. Preliminary design part, where you will set your components, and you will call that as your first phase of the design. You'll fix wing parameter, you'll fix fuselage parameter. If you're designing or fuselage or any component, you'll fix those, and you call that as preliminary design phase. And then you will go a detailed design process. Okay, so this is our overall aircraft design phase. Here, by using this software, what you can do, you can complete this phase, that is conceptual design phase. Suppose you have once okay, let's consider that you are now you are from a customer organization. He or she or the customer or complete organization, they may ask you, I want one aircraft. Inside that aircraft, only my parents, me, and crew members, they must accommodate. So can you design such kind of aircraft? So as per your requirement, company or organization, those who are designing aircraft as per your requirement, they will proceed accordingly. They will not go for passenger aircraft design. They will not go for military aircraft design. They will not go for helicopter design. Okay, they will go more specifically with respect to your requirement. Okay, so directly they don't go for design. Directly they don't go for the manufacturing. What they will do initially, they will use the concept knowledge. They will discuss with the other engineers, those who are in their company or in their organization, and they will plot that overview design on a sheet of paper, and they will show to the customer like this your design may look. Okay, so it will take time. So here the major role we can use, or the software what we have here, Open VSP, we can use this and we can show to our customer that the design what you are looking, each and every component, it may look like this. So that's called a visual design. Once customer satisfied with the model like this, then you can proceed for the preliminary and detailed design. Okay, which means you must get approval from the customer, then only you can proceed for the detailed design process. Suddenly, if you proceed for the detailed design, who knows after manufacturing of each and every component, customer if he rejects, then your material you may lose, human effort also you may lose, and of course there may be huge loss to you and your company, and how you pay a salary to your employees. That's a big problem. So that's why we will use this kind of software where we can analyze our design component, where we can design our design components that may be wing, fuselage, engine, okay, or empennage section, or fuselage section, okay, or in the fuselage we have set of different section. That also we can do. Okay, I hope you understood why this software is required, what is the necessity of this software, what we can do with this. Yes, is that clear?
Yes, sir.
Yes. So in this software, as I told you, we have like this different components. All these components, they are the default components. Come to fuselage, and I will delete this. I'll just use wing component. So how to add wing component? You have to just choose that. You have to add. As soon as you click on add, you can able to see that component on your VSP window. As I told you, automatical browser window. Different component window. I will choose fuselage. I will add. Here we have fuselage component window, and again I will go for the different component stack. Add. Here we have stack component window where we have design parameters. Okay. We also have ellipsoid. We also have human. I'll just select the human. Add. Okay. You can able to see. Okay. You can change that human. Uh, you can also and okay, male to female, and you can change height, mass, age. Okay, and you can change the gesture, whether you want to make the woman to sit on a chair or something like this. These all things can be done. Okay, which means if you want to show that this particular male or female, he or she is a pilot and sitting in front of the cockpit. So accordingly, you can move, you can fix wherever you want to fix. Okay, so what I mean, here you have set of components, whichever component you add component. Now more specifically, I have chosen the wing, which means I am on wing. I have selected the wing. Okay, so here you can able to do changes for that particular component itself. You can change the span, you can change projector span, you can change area of the wing. Okay, and here in this section you can split into two, three section, and you can also do the changes more specifically near the root chord and tip chord like this. And if you want to change the sweep angle, you can change like this, or else you can type instead of dragging. Just type. Suppose you want to maintain 10-degree sweep angle, you can type and enter. If you want to add the aerofoil, you come to this tab where you can add aerofoils. Just a minute, let me delete all other components. I'll just take the wing. Okay, so if you want to delete any component, just click on that component. Okay, come to geometrical browser. Here you can able to see delete option. You can delete. Okay, select that component and delete. Select, delete. And if you want extra similar kind of one component, you can copy and paste. Here we have two wing component, one above the other. So like this, you can translate that. You can come to X form. In each and every component, we have general option and X form. General option is option where you can give the name to your component. Okay, suppose you are done with your wing, you can call this as my wing model. Enter. Okay, and you can change the wireframe color. Wireframe color is nothing but it's like a wing without skin. Here you can able to see only wireframes. Okay, you can change the wireframe color blue to, and now it's one above the other. So what I will do, I'll just translate this. Okay, now here you can able to see just a few second back what I've done, I've just copied and pasted. That's why here we have two wing. If you don't want this, just delete. Okay, we will use only one wing to understand about the different tabs what we have here. As I told you, in each and every component we have general option where we can give the name about our component. We can change the wireframe color. We can change the material. Suppose before adding any material, ensure that you have done the shading. Shading in the sense like this. You have to come to your geometrical browser. Okay, you can shade like this. Here we have shade option, shade. Okay, so after clicking on the shade, you can come to general for material. Now you can add material, whichever material you want to add. If you want to add aluminum, just select that. You can able to see aluminum material has been added up to this wing component. If you want to add any other, you can just select and you can able to see that particular material will be added up. Red plastic. Done. For that component, the material it may vary, right? Okay, so as per your requirement, you can add the material. Okay, and also here we have one option that is NUMW. NUMW is nothing but number of wireframes. Number of wireframes. Now, to observe the wireframe, what you have to do, you have to again go to geometrical browser and you have to click on wireframe. Okay, if you click on wireframe, you can able to see your wireframe of the wing. If you want to shade, you can shade like this. If you don't want to shade, if you want wireframe mode, you have to click like this. Okay, and if you want your wing uh, only sketch kind of thing, like we used to observe, especially in the textbook. Okay, where we can able to see wings, top view, front view, or side view. Okay, on a 2D sheet or 2D paper. So that also we can able to see. Okay, how? Just you have to click on texture, or you can click on none option. Better, that will be the right procedure to get your sketch mode like this. So I'll give you 5 minutes time. Once just go to Open VSP software, add wing component, and just observe what we have in this wing component. Okay, under this general, what we can do, under this X form, what we can do translation and all. Okay, just observe once. Only I'll be on mute for 2 minutes. I hope you are doing. Yes, please.
Yes, sir.
Okay, now just concentrate here. I will discard. Suppose you have messed with your model. You don't want to save. Just click on discard. Okay, like this. You discard. Under about this stress, and this can get can wireframe, but suppose if you aerofoil, can click here. Only lower profile we can able to see, not inner one. Okay, you can shade. You can go to none option to get the sketch mode like this. Okay, and here we have view option where you can get the top view of your model and front view, left view. This is the root chord, this is the tip chord. So that's why our left view of this model, it will be something like this. Okay, we also have ISO view. So I'll share this so that we can able to see clearly. Suppose if we want to get two window in this Open VSP, or if you want to observe four windows, that is in each and every window, if you want to observe one view, something like this, top view, and one more view ISO view, one more view side view, and front view of one model. Okay, for only one model, if you want to observe four views, then you can go to window, you can click on four window option. Okay, if you want only one window, click on the one option. If you want to horizontal window, click like this. You'll get two windows of this open VSP, but that will be in a horizontal form. You can able to see horizontal. If you want two vertical window, you can click on two vertical window like this. And how it indicates that you are on that particular window, this boundary red color indicates you are on that particular window. Now I will click here, so which means you can click and you can do the changes accordingly, and you can observe the changes for that particular view. Okay, and if you want to observe ISO view, top view, side view and front view for the particular model, then you can click like this for window. You can go to wireframe mode or texture mode, okay, or any other surface mode, and you can work accordingly. Okay, so why we use this for window option? Just to observe our model's orientation. Okay, in each and every view, so that we will know. Suppose you are uh, changing the span. Okay, so the top view, you can able to see the top view. Yes, of course, I'm changing the span, so that's why the overall length of the wing is increased. And here I can feel that changes. Right, like this. And if you don't want the access toggle, you can off this access toggle. So I suggest you better to on this checkbox of access toggle. You will know the orientation of your model. Okay, which means suppose you have only one window. Okay, for each and every component, you can able to see a reference point. This is the reference point. From this reference point, we have a red line, light green line, and blue line. Okay, and that is nothing but the model orientation is 000. Okay, which is nothing but the particular model is suppose X as X and Z. Reference point of the model is X. Okay, this one. Then and that reference that model got X location means from this 0,0. So which means from this 0,0 to this point, the length okay, point it may be meter, or be that upper limit. Here we have unitless number. So later you can convert that particular given value into your unit. That may be the value. Suppose if you want to go with centimeter and you have called from this point to this point, overall X location is 10 centimeter. So just type 10. Okay, and at the end, when you export that file, so that time it will ask you the input value what you have given, that was in which unit, centimeter, meter, or feet. So you have to choose and you have to get that file unit accordingly. Okay, similarly you can see Y location. Here we have symmetry of this model. So if you don't want the symmetry, just off this checkbox. See, this is the symmetry about the plane, that is X and Z plane. Now I have disturbed Y location, so that's why you can able to see the gap. If you don't want to show the gap, just don't disturb the Y location, enter 0, so it will be attached properly. Okay, if you're maintaining the distance, or if you're translating along X location, then you can be able to see the gap. Okay, so that's why if you want any symmetry wing, better to maintain X location 0 and no need to disturb this. Okay, and suppose you have fuselage like this, and you want to fix your fuselage, no, sorry, if you want to fix your wing little bit forward, you can click on this X form. You can translate. Sorry, I have clicked on the fuselage. We know that we have to click on the wing because we have to translate that wing forward. Okay, so where you want to fix, here or here or here, you move accordingly, or you can type. And before assembling that wing to the fuselage, ensure that you have fixed any one component. You must fix any one component. So I suggest you always fix any one component and you fix bigger component. Suppose you have done with your engine, you have done with your wing, you have done with your fuselage. So among all these three components, your major component will be the fuselage. So click on the fuselage and don't disturb to this fuselage. Call that component as the reference component. With respect to that reference component, you translate other component, that is, you can do the X translation, you can do the don't do Y translation. If you click on the Y translation, then you can able to see they will be mixed up with the wing. Okay, you want a symmetry, that's why maintain 0, and you can able to see that along Z it is at neutral point. If you want to fix above the fuselage, you can go forward. If you want to fix below the fuselage, go down like this. Okay, suppose you want to fix above the fuselage, like this you can fix, and whether it got fixed properly or not, to check that you can go to 4 window option. You can able to see here you have ISO view, here you have, okay, let's keep this view as a top view, and I will click here and I will keep this view as a front view, and I will click here. So during assembly time, by using X location, you have fixed your wing properly or not. Okay. Yes, it is below. Yes, below the fuselage. And done. Now you can able to gap. So again you can click on wing and little bit you can translate downward. Done. Okay, material to material attachment, no problem. Now you can able to see the gap here. Okay, so how to overcome that gap? You have to come to this general option and you can increase the wireframe, because now if I click on this wireframe, you can able to see the number of wireframes are very less. So you can increase like this. By increasing the number of wireframes, you can smooth your geometry. Now once again I will shade. Now you can able to see there is no any gap, right? So which means for each and every component we have this number of W. There is nothing but number of wireframes. Increasing the number of wireframes, you can increase the smoothness of your model or smoothness of your component. Okay. So for whatever I told, any doubt, any question? I hope I'm audible.
Yes, sir.
Any doubt? Any question?
No, sir.
Okay, fine.
No, sir.
Okay. So you understood about the general tab, Xform tab, where you can translate your model and also you can rotate your model. Okay, suppose you want to rotate fuselage, you can rotate like this. Unnecessarily don't play like this because it's not a right design. Better to maintain this and this also at equilibrium point. And if you want symmetry of this fuselage, that also you can get by using plane. You want symmetry with respect to the plane or with respect to the axis. If you going with the plane, click any one plane or you can on any checkbox. You can able to see here you have the symmetry. Just the thing is that you have to translate that. Okay, better to translate. Okay, you can able to see. Have you observed this kind of fuselage? Wing, only one wing, but two fuselage. If any customer asking this kind of design requirement, you can show like this. My dear customer, you asked us that your fuselage has to be two and wing has to be only one. So this is what your design looks like. Can we proceed with this? If he says yes, but you can tell him that no, we can't proceed with this because aerodynamically it will be not perfect. We can fix two wing, but not two fuselage for only one wing because it doesn't give any sense, right? No, Yashvi and
Yes,
Jayashree.
sir.
Yes. Now, can anyone justify through this statement why is it so? Why not give any sense? I have given hint also.
What, sir?
If any customer asking this kind of design, design engineering, design and manufacturing. I hope you got my question. Hello.
Hello.
Yeah, I hope you got my question.
Yes, sir. Sir, actually, in these structure, we have two fuselages and only one wing. So, I think there will no enough lift to lift this whole structure. First of all,
Yes,
there
very
will
good.
be more
Very good
drain
point.
instead.
Yes, very good point. So that's why we have this topic. Load factor N is equals to L by W. If you have any body, if you want to lift that body, or if you want to generate a lift to this body, ensure that you have designed this body aerodynamically and you have increased the lift force for that particular weight. Of course, if you design any body and if you design aerodynamically, of course, the weight will be acting downward. Weight is nothing but one kind of force which is acting downward. Okay. If you want to lift that complete body, you must increase the lift force as compared to the weight force. Then only the body will get lifted up. That's why we have one topic that is called as the load factor N is equals to L by W, lift to weight ratio. Yes, you can justify to the customer. You can tell that the body's weight will be very much larger as compared to the lift force, because this fuselage don't have the capacity to generate the lift, and the component are two component, two fuselage, and wing is only one component, where the wing will not generate that much of lift for these two components. So hence the body will not at all fly. So we can't go for that kind of design, my dear customer. Can we go for other? Because customer will not be aware about the design parameter. You must justify to the customer. You must convince, or you must convey your theoretical, practical, aerodynamical, structural, or overall design aspects to the customer till he gets satisfied. Then only he or she or the organization or the company will give their requirement, and hence there will be a tie-up and you'll be doing the business. So that's all about our aircraft design, and that's why we have the software. Okay, and we also have the sub components. Let me delete all this thing. As I told you, if you add any component, okay, this two will be the common tab: general and exform. General and exform. If you're adding a group of sheet, okay, here we have group of box. We also have group of seat. Okay, so group of box design parameter is length of the box, width of the box. I'll just translate this. I'll make that separate. Yeah. Okay. And height of that box, which means you can use this kind of component to fix below the fuselage, and you can call this as a cargo part. Okay. And of course, if you're adding a fuselage, you must also use the group of seats. Okay. Where you can change the number of rows, which means you can increase number of rows like this, and you can and you can and also you can cross section. We let me delete this box. It is disturbing us. Yeah. Increase the cross section type, lips to circle, and you can increase this design parameters like this accordingly. Okay, you can jump to the next cross section, and you can change the cross section type, and you can increase, and you can come to the seat. You can translate accordingly. Okay, and you can fix like this. Now roughly I'm showing you, or else you can use 4 window option. You can fix perfectly like this. Where you want to fix, you can fix accordingly. Little bit forward, backward type. Okay, like this you can adjust accordingly. So what I want to convey, is that in each and every component we have general, exform, and that particular component's parameter. Okay, group of seat parameter. Under this design tab, you can able to see seat width, seat height. Okay, Here you have group of seats, so it will implement to all the seats design parameters. Okay, back better to go with only row so that you can understand. Yes. Okay, like this we have design parameters for each and every component. Fuselage design parameter, length, cross section, skinning, where we can do the modification, and modification is like updated version of skinning. Okay, X form, where you can come to each and every cross section, you can change the cross section type, which type of cross section you want to add. Like this, you can jump to each and every cross section, you can change the cross section type. And save, which means now currently I am on this cross section. Blue indicates you are on the third cross section. If you want to come forward, you can click on, so which means from here to here, one cross section. Okay, and from here, second cross section, from here to here. And from here to here, third cross section, which is nothing but this one is the third cross section, this one is the second cross section. Between that we have sections, that is like a wireframe, that's like a number of W. Okay, so that also can be done the changes. You have to come to the skinning, or you have to come to the general. Okay, where you can increase number of N. Okay, this is for overall fuselage. Better to come with this. Okay, you come to this X section, and here you can increase to that particular cross section. Okay, if you want to add 50, you can type 50 and add. Okay, which means at each and every cross section we can do the changes. We also have same in case of wing. Okay, here in this wing we have section. Sub is nothing but sub component. You want to show edge. Call this as slat. Is it looking like a slat? Yes or no?
Yes, sir.
Yes. If you want to show the flaps, just add and use that subsection parameters, center U, center W, where you can translate forward and backward. That is the center W. Center U, where you can move root side and tip side. Length of that subcomponent you can change accordingly, and width, and also theta. If you want to tilt, you can tilt like this. If you're okay with this, just leave as it is. So you can call this as your slat and this as your flap. Okay, or else, of course, if you don't want to show high def devices, if you want to show only aileron, okay, or flaps or radar, so with the help of this subcomponent, you can show high lift devices or your control devices of an aircraft. That is the use of this tab subcomponent. Planform, where you can change your wing planform, span, projector span, aspect ratio, So to design with wing component, ensure that you know your parameters. Okay, if you want to design any wing, of course, in this Open VSP, you will be getting the default wing. How you can use that default wing and how you can change that default wing to your wing, required wing, or as per the customer, what he's looking. Customer, he will not give 18. Okay, he may ask you, or he may give his parameter that my wing parameter, it must be like this. I don't want 18 feet or 18 centimeter. Okay, I want to see my wingspan 20 or 20 feet or 20 centimeter. Okay, so you can change accordingly as per your requirement. Okay, as I told you initially itself, here we have default component. We have to use this default component and we have to give our parameter. Parameter is nothing but if you want to design a wing parameters: span, chord, wing area, aspect ratio, and also we have root chord, we also have tip chord, we also have our sweep angle. Okay, and you can able to see, I will just go to front view. Okay, okay, now you want to keep unhandle or dry handle. Unhandle positive, dry handle negative. Okay, these are the wing parameters. Similarly, if you want to design fuselage parameter. Okay, and wing is not a easy task, because to proceed with wing, you must know wing parameters, even which aerofoil you want to add. Because we know that here we have set of aerofoils: NACA series aerofoil, 6 series, 4 series, 5 series. So which aerofoil is suitable? Hmm. So we can increase the lift component with the help of this series. So for symmetrical, it will be from 0, 0, and for unsymmetrical, it will be from minus, which means even at 0 degree angle of attack, we have some amount of CL. That's unsymmetrical aerofoil. So like this, you can change the aerofoil parameters. Suppose if you have chosen 4 series, you can change that parameter. Suppose if you want to keep thickness to chord ratio 21% and camber some 2%. 2% is nothing but 0.02, and camber location you want to show 40% from leading edge. 40% is nothing but 0.4. Enter. So the aerofoil is NACA 2421. If you want to use this aerofoil, you must add your parameters accordingly. If you want to go for single aerofoil, similar aerofoil NACA 012. So 0012 is nothing but no camber, no camber location. So which means no camber here, no camber location. 0012. 12 is nothing but thickness to chord ratio. Oh, sorry. 11%. So which aerofoil you want to add, you have to go accordingly. So this is all about today's topic. I suggest you please add each and every component, observe each and every component. After adding each and every component, observe the component window. Okay, like this we have each and every component. If you are adding propeller, you will be getting that component window. That component window is nothing but propeller component window, where you have first two option or first three option, it will be same: X, form, general, and subcomponent. And you'll be able to see the design parameters of that particular component. Okay, so that's why I'm teaching about this for the higher semester students, where they will be coming across different basic fundamentals, that is structure 1, structure 2, aerodynamic 1, aerodynamic 2. Okay, at this peak time, that is 7th semester or 8th semester, they will be knowing about all the basic concepts, and in this class or this kind of Open VSP session, they can implement all that knowledge, or they can use that knowledge to design any aircraft components. Okay, so I'm done with today's session. Any doubt? Any question?
No, sir.
No, sir.
Uh, I hope both of you understood what we have done today, what we understood, what was the overview of this software.
Yes, sir.
Yes, sir.
Now, Yashvi, can you tell me briefly what we have discussed today, what we understood? Briefly, in 2 minutes. I hope I'm audible to you.
Yes, sir.
Yes, please proceed.
सर इन इस सॉफ्टवेयर में बहुत सारे कंपोनेंट्स हम ले सकते हैं लाइक विंग है फ्यूजलाज है नोजल है और हम यहाँ पे एयरक्राफ्ट की लाइक पूरी स्टडी कर सकते हैं उसके अंदर हम चेंजेस कर सकते हैं कि हमको कौन से पैरामीटर्स के लिए अब विंग है तो उसके लिए हमको क्या चेंजेस चाहिए रिब्स चाहिए या उसकी हाई कितना रखना है उसकी लेंथ कितनी चाहिए और वो सब उसमें कौन सी एयरफॉयल यूज होती है वो एयरफॉल भी हम चेंज कर सकते हैं उसके पैरामीटर्स चेंज कर सकते हैं और उसके अलावा हम ये फ्यूजलाज में भी चेंजेस कर सकते हैं कि विंग हमको कहाँ लगानी है कितने डिस्टेंस पे लगानी है और वो बहुत सारे चेंजेस कर सकते हैं हम
Yes, very good. सही है. Next, what you want to comment? Jayashree?
Yes, sir.
Yes.
Sir, in this software, first of all, we have, we can say that ready-made parts which we can modify,
Mm.
first of all, which are
Yes.
fuselage,
Good point.
wing, and all that. And according to the
Mm.
customer requirement, we can modify them. There are different fuselage. There is geometry window in which, for different parts, we can change the parameters of that particular component. First of all, we are having general and X form in all the components, in which we can name the geometry which we are going to draw, and then we have X form in which we can adjust the wing or any component in whole the in our design, and we have some planar in which we can take a plane about the plane we can divide that particular component. Then we
No, no,
have
we can get the symmetry of that component. Symmetry.
symmetry.
Yeah. We
Okay,
can get the symmetry
but
about the plane and symmetry about the axis.
sir, you were changing the distance between both, na? So I thought,
No, suppose if you have a wing, you can get the
hello.
symmetry of that wing along the axis. Like this.
Okay, so we just
Yeah.
can check the symmetry or see the symmetry of that object
No, no, no.
accordingly.
Suppose you have the component something like this.
Yes, sir.
Suppose if you have a component, okay.
Yes, sir.
Now
Huh.
this is your half component. Okay.
Yes, sir.
If you want the symmetry of this wing component, you can get the symmetry about the plane like this, or you can also get the symmetry about the axis, x-axis or y-axis or z-axis. If you don't
Okay,
want
sir.
symmetry, just click one option. Okay. So
Okay,
better
okay, sir.
if you are going with the wing, if you're going with the wing, click on this xz plane so that the symmetry will be perfect. Okay.
Okay,
About
okay,
this.
sir. Yes, sir.
Yes, good.
Yeah, yes, sir. Understood, sir.
Yes, very good to both of you because whatever I had told, whatever I delivered in today's session, at the end, briefly you have told what you have learned. So it ensures me that you were listening and you understood something very special and unique about this Open VSP. Right now, yes.
yes sir
Yes, sir.
So before I end this session, do you have any question, any doubt?
no sir
No. तो अभी तुम्हें क्या करना है? Now what you have to do? You have to do a small task or you can call a homework. What is that? You have to add each and every component. Okay, you go to geometrical browser. Okay, one by one. Okay, so first you go with fuselage, add, done. Then click on the fuselage, observe main tabs, because for each and every component, general expand subcomponent will remain same. Observe the main tab, that is, if you are going with the fuselage, design tab, X section. Okay, and explore to yourself with respect to that component tabs. If you're done with this, then delete, add next component, then check that component tab, main tab. Under this plane, we have wing parameters, we have section. Okay, and section where you can split wing into two section. Okay, you can work on this first section, and again, if you're done with the first section, you can jump to second section, and you can work on the second section like this accordingly. That's the main thing. Each and every section you can add the aerofoil. So this blue indicates you are on that particular aerofoil. Route 0, 0, you can move forward like this. You are here now. Blue indicates you are here, and you can go to tip side. Accordingly, you can change the route code, tip code at each and every section. If you are on the first section, this one will be the root code, this one will be the tip code. If you jump to the second section, okay, this one will become the root code, this one will become the tip code. You can able to see. And you have aerofoil where you can do the changes. Okay, blending, as I told you, blending and modification is a tab where we can do extra changes to our wing. And you have all other components like this. You add each and every component and understand about the main tabs. Okay, what kind of changes you can do, or how this tab will be useful for you to do the changes accordingly. Okay, understood now?
Yes, sir.
Yes, then all the best, do well. If any doubt, write down. Tomorrow we can discuss about it. Okay,
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 sir.
sir.
okay then, bye bye, good night.
Thank you,
Thank
sir.
you, sir. Good night.